We're in Algebra 2!
You're not
Woohoo!
yeah.
Today's date is January 14th, 1/14. We are in Algebra 2. We're on lesson 4-11. I forgot to assign the homework last night, on Friday, 4-10. Hopefully you know what's going on because this is going to be a harder version of 4-10. Thank you, Chris. All right, so example 1. We have a particle represented by the letter P. Particle expressed in terms of this guy, t minus a minus t, and t minus b. There are 3 of these terms. We also know that a is bigger than b. This guy is important. A is bigger than b. All right, so we have these 3 things. They're being multiplied by each other, and I'm trying to figure out which value is greater. The position where t is bigger than a, the position where t is less than b. We can say these values are both equal, or there's not enough information to tell. All right, so let's just think about that problem for 5 seconds and how hard that is.
Okay. What?
I'll be honest, when I first saw this problem, I had to look at it for about 60 seconds before I realized, oh, okay, this is where you start. And then the rule of thumb for teachers is you need to give your students at least 3 times the amount of time for whatever it takes for me. So if it takes me 10 minutes to do a test, it should take you 30 minutes to do a test. Hypothetically. Okay, so anyway, let's go ahead and show you how to solve this. So there are 2 cases, case A and case B. You're following with me. So in case 1, t is bigger than a. We see that. Case 1, t bigger than a. We nod our heads. That means if I come back up here, that means t goes right in front of a, right there, which means t is bigger than a, which is bigger than b. Nod our heads. So far that makes sense. We understand case 1. Case 1 matches with letter A. I don't like greater than or equal to because it makes it very vague. Let's go ahead and pretend that we have numbers. Let's choose numbers 3, 2, and 1. 3 is bigger than 2, which is bigger than 1. I think we can all agree that 3 is bigger than 2, which is bigger than 1, right? We can nod our heads? We can nod our heads? Uh-oh, Chris does not believe that 3 is bigger than 2, which is bigger than 1. All right. Don't worry, I can bring one of your elementary school teachers here to explain. But let's go ahead and plug in each of these values then. If t is 3, this value is going to be 3 minus 2. 3 minus 2. We're being so silly. All right, participation card. That's ready to go. What is this next going to be? Teflon.
2.
What?
2. Minus 3. Good. She's in. Next is going to be James.
3 minus 1.
Perfect. And I need someone to simplify each of those for me. Who's going to simplify all 3 of those for me? Yeah, Fiona.
What?
1, 2.
All right. I don't care what number it evaluates to because these numbers were hypothetical. I could have chosen 5, 4, and 3. As long as they're bigger than each other. I just did that to make it easier for us. What I really care about, if it's positive or if it's negative. Because a negative times a negative is a positive and so forth. So a positive times a negative times a positive, quiet raised hand is, and I should have some cards in here already. Andrea, it is a negative. So on this case 1, put a giant negative sign.
Give it to me.
This one is a giant negative sign. Thank you, Andrea. This is a negative. Okay, let's do the next one. Let's get all of us in. T minus a. I'm not even going to ask for numbers now because you should know that I'm going to do 3, 2, and 1 again. I could have done 10, 9, and 8. I just choose the easiest things for me. You better not spill that, Chris. All right, so from here, I need to know if this thing right here is a positive or a negative. T minus a. Is it a positive or a negative, Eva?
Positive.
It's a positive. I agree. Eva, your card is in. This a minus t is positive or negative? Gio? Negative. And I agree it is... Wait a second. Careful here, Gio. Because it's 3 minus 1. What's up? The first one should be negative. T minus a, it should be negative. Sorry, Eva. Sorry, Eva.
He's in 2 good of a mood. No, that is not true.
What? It is a negative. Sorry about that. T minus A. 1 minus 3 is a negative. Geo, A minus T is? A minus T is a positive. I agree, because it's a 3 minus 1. Thank you, Geo. And then finally, T minus B. Is that going to be positive or negative? Chris, do you have your card in yet?
Yes. No.
Okay, Chris, what is it?
Wait, what?
T minus B, is that positive or negative? 1 minus 2.
It's positive.
1 minus 2.
Negative.
1 minus 2.
Negative. Positive.
I'm just going to keep saying it until you switch back and forth.
Positive.
Be confident in your answer. 1 minus
It's
2.
negative.
It's a negative. All right, so, and then finally, a negative times a positive times a negative is a positive.
Wait, it is.
This one is going to be a positive. This one is a negative, this one is a positive. Again, we don't really care about what numbers because we don't actually know what numbers they were. We just put those numbers in to help us out. We knew that in case 2, that was positive. In case B, this one was positive. In case A, it was negative. Well, which value is greater? Is it A, B? Are they both equal, or is there not enough information to tell? What do we think? Shout it out. Which one is greater? A positive, a negative? Are they both the same, or is there not enough information to tell? Obviously, it should be the positive. There it is, B. Positives are bigger than negatives. I'm pretty sure. But what would happen if I had a negative and a negative? If both of these were negative, then there wouldn't be enough information to tell. And here's a cool key fact for you, and write this down. It will never be option C. Ever, ever, ever. Not in ever.
Like, you mean like legit?
You cannot have those values equal to one another because we don't have actual values. You can't say 2 is equal to 2. You can say, oh yes, they're both positive. That doesn't mean that they're equal. Just because they're both positive does not mean they're both equal. It just means one could be a 1, one could be a 3. They're not necessarily equal, but they are both positive. All right, let's go to example 2. All right, this case, A is bigger than B, but now I have 4 terms instead of 3. All right, so I'm going to do case A in yellow. All right, so you're going to try to do this table that we did, case 1 and case 2. You're going to try to do this table in your head. It's harder now. In your head, T is bigger than A. T is bigger than A. So T is big. In fact, I'll even help us out by writing this. T is big. We'll say T is big. A is medium. B is small. In this yellow case, where T is greater than A, T is the biggest, A is the medium, and B is the small. We can all agree that from this fact and this fact, right? Right. I only see a few heads nodding. That's not good. There it is, okay. So from there, is T minus A positive or negative? And everyone's going to vote on this one. Everyone's going to get XP as long as everyone does it. Positive is thumbs up. Negative is thumbs down. Is T minus A positive or is it negative? A big minus a medium. It is a positive. A big minus a medium is positive. So I'm going to give all of us some points. Okay, what about A minus T? Is that positive or negative? A minus T, is that positive or negative? A minus T, medium minus big. Good, you guys got it. It's negative because it's a medium minus a big, which is negative.
Can you speak any other language besides Spanish?
Not really.
Not really?
Not really.
Can you speak Spanish?
I could, but I'm going to do English for the rest of this lesson. All right, what about T minus B? T minus B, is that positive or negative? Do your thumbs once you get it. T minus B, positive or negative? Very good, yeah, it's positive. Everyone got the thumbs up, everyone gets the XP. What about B minus T, positive or negative? B minus T. Very good, yeah, it is negative. So in this case, in the yellow case, positive times a negative times a positive times a negative is Thumbs. Let me see thumbs. Positive thumbs up, negative thumbs down.
Wait, what?
I'm asking, when I multiply each of these four things together, do I get a positive or a negative? Very good. It is a positive. All right, we're doing the same thing now for blue. Everything is blue for B. T is less than B, which means T is even smaller than B. That means I have A, then B, then T. A is the big, or the 3. B is the medium, and T is the small. All right, so T minus A. In the blue case, where T is less than B, is it positive or is it negative? Thumbs. T minus A. I don't see half of them. There it is. Yes. T minus A is negative because it's a small t minus big A, which is negative. Y'all got it. Nice.
Oh.
You're not getting it?
I don't get how you choose which one's big, medium, and small.
So right now I'm looking at T is less than B. So by me saying T is less than B, Fiona, you can look up here on the overhead, that means that T goes right here. T is less than B, so it goes B is greater than T. So that's the order that I decided. Got it? Yeah, I could have explained that better though. All right, so A minus T, big minus small. A minus T is, thumbs up, thumbs down. What are we saying, Chris? It is positive. Nice. And Fiona asked a good question. All right, T minus B, positive or negative? Thumbs up, thumbs down. T minus B. Negative, I agree. And B minus T, positive or negative? B minus T now, positive or negative? Good, 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 good. All right. All plus 10, all plus 10. All right, so from there, when I multiply all four of those together, what do I get? Blue times blue times blue times blue is positive or negative? Thumbs. Thumbs up, thumbs down. It is positive. All right, so we know that both A and B are both positive. So what's your answer? A, B, C, or D? Hold up number of fingers. A is 1, B is 2, C is 3, D is 4. Good job. You guys are killing it. Yes.
Both A and D? I mean A and D?
Yeah.
You can't choose both A and B. You have to choose one answer.
What are you even?
Which value is greater? Well, these are both positive, and you can't say that they're equal because you don't know exactly how big they are. Therefore, there's not enough information to tell. D was the correct answer. Good job, guys. And that's hard, and you guys are getting it. That's awesome. All right, we have one more example, and this is the, it's a little bit hard, but I think we can get it. It requires one additional step. All right, so this time I have 4 of the same values. I think it's T minus A, T minus B. Okay, it's slightly different. T minus A, T minus B, B minus T, T minus B. And this time I have 4 inequalities. Well, I guess 3 inequalities with 4 values. All right, the number of times at which the particle's position is 0. Remember, P represents the position. The position is 0 means P, this P represents position. That P is now 0. Yeah, you guys are getting it. Okay, so P is 0, which means I'm going to set each of these to 0. Let's do that down here. So that means that 0 is equal to T minus A times T. Oh, I'm going to pause right here because I want to do a shortcut. I know that the 0 product property is going to tell me that each of these 4 things can be set equal to 0. That means T minus A is equal to 0. That means T minus B is set equal to 0. That means B minus T is set equal to 0. And my 4th one, T minus B, T minus B is set equal to 0. I set all 4 of these equal to 0. Are we okay with that? That's a 0 product property. Because P is 0, because the position is 0, the 0 product property tells us any 4 of these can be 0. And to solve for all of them, we need to solve for each case. So solve each of these for the value of t. Pretend t is x. If I solve for t, add a to both sides, t is equal to, quiet raise hand. If I'm solving for t by adding a to both sides for this first equation, T is equal to what value? Quiet raised hand, James. T is definitely equal to T, I agree. Teflon.
A?
A, yeah. You add A to both sides, thank you, Teflon.
I said that.
I asked for a quiet raised hand. All right, solve for this
You
one.
told me James. That's kind of mean.
T is equal to,
Oh.
maybe it's a compliment. T is equal to,
No, I didn't say it wasn't a compliment.
the second one, quiet raised hand. T is equal to, Geo. B, there it is, Geo.
You are so smart. You are so nice.
T is equal to what value now? Add T to both sides. T is equal to B. Add B to both sides.
Wait.
Nope.
Wait, how are you getting these equals?
I'm just solving these for T. Solve each of these for T.
So that was T.
Put it in subtract, please.
So this one, I do what to both sides to get B by itself?
But for the
B,
for the
B,
subtract to be,
B.
What's up?
For the third one, what? B minus B. Wouldn't you subtract B so it's okay, never mind.
And then you divide both sides by, or multiply by both sides by -1. Yep, you saw it. Good. I could have also additionally just added both sides, or added T to both sides. I just chose to put them in there. There's two T minus B's. I did it on purpose. It would be too easy if I just did one of them squared because it gives too much information away. All right, so
Your T's look like F's. It's like, ooh.
I do need better penmanship. I know.
Why don't you just do
I'll
like
work on it for you,
why don't
Stego.
why don't you do a little curvy bottom thing at the bottom?
All right, so how many times is the position 0? Well, the position is 0 at T equals A. So this is one of them. Where's the other position? T equals B. I just repeated it 3 times. It has a multiplicity of 3, but it's still one spot on the graph. So how many times does it intersect the 0 axis or
Dude,
the x-axis?
It's T equals B to the third power.
3. He was like, 4.
All right, guys, come on. Let's focus here. Let's focus here. There are 2 values of T that will make this polynomial,
So it's square?
this particle's position, 0. What are those 2 values? There are 2 values.
T and B.
T equals A and A equals, wait. T equals A and T equals B.
Yeah, A and B. Those are the 2 values. Even though that we have 4 things that we solve for, since this one was repeated 3 times, has a multiplicity of 3, we discard basically the other 2. We say that there are 2 positions. So let's go ahead and write the number 2. This one actually has a number. Not only is it positive, but it is the number 2. We actually found a number, which is really cool. All right, this next one is a tricky question, but I'm going to give you a cool hint.
But we're done.
Well, we don't know which one is greater. Is 2 greater than this one? Well, what is this one, right? So, the position when T equals X. Well, that means that when T equals X, this X can be substituted out for, if T is equal to X, this X, say it again.
T.
So change this to a T. Is that a better T, Sego?
Yeah.
All right.
When you curl the bottom, it looks like
That means this is a T, which means don't think about the 0. I have T is greater than A, which is greater than B. Again, we're going to go through all of this.
that means that X or the T equals X is greater than 2. Because we think T the greatest number.
Well, we need to figure out if this whole polynomial is positive or negative now. So we know T is bigger than A, which is bigger than B. So T minus A, is that positive or is it negative?
Positive.
T minus B,
Positive.
B minus T.
Negative.
Say it again.
Negative.
T minus B.
Positive.
Positive times a positive times a negative times a positive is a?
Negative.
That means B is a negative.
Does that mean
Again, the question was, which value is greater?
No.
Which one is greater, 2 or a negative?
Two.
There's our answer, done.
I'm very
And that says the position is zero.
How is this
How'd you
supposed to
get
help
a,
me in life?
how'd you go from 0? Wait, how'd you get a 0 and then go to 2?
How did I get a 0 and then go to
It
2?
says A is number of times at which the particle's position is 0.
There are 2 times. Time equal to A, time equals to B. There are 2 values of T. T is a time, right?
This is gonna be in the test, right?
This is going to be on the test. This is going to be on the. This is going to be on tomorrow's quiz, and this is going to be on the test.
What? What is this gonna do in my life?
Applying logic to your
Wait,
surroundings.
can I actually ask a question? Like, who decided to put letters in math? Like,
I know.
Who thought of math?
I should know where or when the first variables occurred, but I'm not exactly sure when. I would guess Europe in
But why?
some centuries
But why?
to solve problems. It's the thing that you're trying to solve.
All
All right, that concludes example 3. If you have questions, I will come around individually and answer them one-on-one, unless you have a class-wide question. You have a class-wide question?
A what?
Do you have a class question or an individual question?
Why do you have to say?
Just say
Whoever
it.
chose me is whatever. Go to my participation card.
I'm sorry.
It's whatever. I'm used to it by now. Here you go.
Oh.
It's okay.
That should be
All
my
right.
16. That was rude.
This concludes our video. Please write your summaries now and then begin on the 2 assignments on Khan Academy.